Let's take a look at the answers to test 1. Number 1, eye color is categorical, and some of you made the mistake for question number 2 where you said eye color is bimodal. That's impossible because eye color is categorical, and we're going to need numerical data in order to make a chart that would be bimodal. Some of you made a case that homework could be bimodal. I gave people credit for that. But cigarettes is probably the best answer because you're going to get a lot of people who smoke 0 cigarettes, and then you're going to get some people who smoke some cigarettes. But if you made a case, I'll give you credit. Of the choices above, head circumference is the best one that follows a normal model because it's biological. It's like heights of people. Anything that's measuring biology is going to be normally distributed or unimodal and symmetric. The dot plot has a standard deviation of about 25, and what you needed to recognize was the center is about 160. So let's say this is this is standard deviation. So 2 standard deviations would be 50, and that would get us to 210, which should be 95% of the model. Anything lower is not enough, and there were some of you that selected 40 as an answer, and that's quite impossible because 2 standard deviations away from the mean is completely outside of the data set. Number 5, only skewed to the right, which means the mean is actually larger than the median. Number 6, a histogram and a stem and leaf and a dot plot are really showing you the same thing. They're showing you almost the same picture. So sort of a trick question, I guess, in a way, but obvious if you knew that. Number 7, you needed to find out the total speeds and by multiplying those two, and then we would take that answer and divide it by 48. Number 8, none of those are true. Certainly Roman number 1 should absolutely not be true. It didn't make a 75% on the test. I can tell exactly what this means. Without knowing the standard deviation, it doesn't matter. I could tell that 25% of the class scored better than I did, or you could say 75% of the class scored worse than I did. It doesn't matter if you know the standard deviation or if you know what kind of distribution you have. Number 9, you needed to figure out the 25th percentile, which is right about there, 30 something, and then the 75th percentile is going to be right about there. That's going to be 40 something, and so the difference between those would have to be 13. And number 10, 2.2 standard deviations above the mean. Most people had a lot of success on part A and B of number 11. Fairly straightforward. Part C, the things I was looking for was a title and labels for your graphs and a label for your y-axis that they were measured in percentages. And these 2 bar graphs, these segmented bar graphs are not the same, and we can see that in these percentages. These are the percentages, of course, that you should have been using here. And the bike and the bus are both off. So this is not independent. There is some kind of association between job classification and mode of transportation. I think everybody had success on number 12. Number 13. A lot of people got the idea that you should have been looking for an upper fence and a lower fence. Got that part. But then they drew their box plot incorrectly. So the other thing I was looking for as I jot down some of these numbers, the other thing I was looking for is a title, of course, and then a some kind of a scale, and the scale that we're talking about is a percentage down here. So some label that these are percentages as it tells you in the question prompt. So we've got a median right around here, and we've got Q1 around there, and Q3 around there. And then we've got outliers because of the lower fence and the upper fence. So the 26 is an outlier and the 4.4 is an outlier. And I gave you these numbers on purpose so you would actually know how to make the whiskers. So those whiskers look like that. Some people didn't quite have their whiskers in the right place. So the sum of the squared deviations was given to you. So we're going to divide that by 50, and that's almost 16. And then you're going to take the square root of that. And some people got dinged, or a lot of people got dinged because they didn't have a percent. Again, standard deviation is going to carry the units of the original data. So the standard deviation for this data set is 4%. And finally, some normal distribution problems. Always make sure you're putting a diagram, trying to figure out what percent are underweight. So the z-score we're looking for is going to be negative, and that comes out to be 6.7%. Part B, now we're given a percent of 4%, and we need to figure out what z-score shows up in that spot so we can find a new mean. So the z-score is negative 1.75. We're looking for a new mean, and our standard deviation is 0.2, so therefore 16.35 ounces. And finally, a similar problem where we're given this 4%, so we're going to reuse that z-score of negative 1.75, but now we need to set the mean to 16.2, so underweight divided by some unknown standard deviation that we're looking for, and that standard deviation comes out to be 0.114 ounces. So I didn't ding people in this question for ounces, but I did in part C. But once again, standard deviation should carry the units of the original data.